When we think of dinosaurs, massive creatures like Tyrannosaurus rex or Triceratops often come to mind. Towering behemoths, ruling a prehistoric world. However, modern science has uncovered a surprising truth. Dinosaurs never truly went extinct. Instead, their legacy lives on, thriving all around us, high above, soaring through the skies. For you see, dinosaurs evolved into birds. Join me now as we uncover the secrets of this incredible transformation, a journey spanning millions of years, from the mighty reptiles that once walked the earth to the feathered creatures that fill our skies with color and song. Our story begins in 1861, in a limestone quarry in Germany, with the discovery of a single, exquisitely preserved feather. This feather belonged to Archaeopteryx, a creature with a unique blend of reptilian and avian features. Archaeopteryx resembled a dinosaur with its toothed jaw and long bony tail, yet it also bore the unmistakable imprint of feathers, a defining characteristic of birds. This discovery ignited a debate that continues to this day. Could this be the missing link between dinosaurs and birds? In China, fossils revealed dinosaurs with a dazzling array of feathers. Among them was Microraptor, a four-winged glider. Its feathers hinted at the earliest experiments in flight. Even Velociraptor, made famous by Jurassic Park, was feathered. These feathered dinosaurs now stand as powerful evidence of the evolutionary link between dinosaurs and birds. These fossils paint a vivid picture of a world where dinosaurs were adorned with a surprising diversity of feathers. Feathers, those marvels of biological engineering, are often seen as synonymous with flight. But their story begins long before the first bird took to the skies. Early feathers, simple filaments resembling hair, likely served a much different purpose: insulation. Just as fur keeps mammals warm, these proto-feathers may have helped small, active dinosaurs regulate their body temperature. As feathers evolved, they took on new roles. Brightly colored feathers, like those seen in many modern birds, may have served as camouflage, blending dinosaurs into their surroundings or as dazzling displays to attract mates. Imagine a world where dinosaurs strutted and danced, their feathers shimmering with iridescent hues vying for attention. In the dense forests of the Jurassic period, a new advantage emerged: gliding. Dinosaurs like Microraptor with their feathered limbs could leap from tree to tree, their feathers acting as airfoils, extending their reach and allowing them to exploit new resources. This ability to glide, honed over millennia, set the stage for the evolution of true powered flight. The evolution of flight in birds is a testament to the power of natural selection, where small, incremental changes over vast periods can lead to remarkable adaptations. From simple filaments to complex aerodynamic structures, feathers played a pivotal role in this transformative journey. The link between dinosaurs and birds goes beyond feathers. When we examine the skeletal structure of theropod dinosaurs, a group that includes Tyrannosaurus rex and Velociraptor, we uncover a startling resemblance to modern birds. These similarities are not merely coincidental, they are echoes of a shared ancestry. One striking feature is the presence of hollow bones. Just as in birds, hollow bones in theropods would have lightened their skeletons, allowing for greater agility and, eventually, flight. This adaptation, crucial for airborne creatures, hints at the evolutionary path from ground-dwelling dinosaurs to birds. Examine the footprints of a theropod dinosaur, and you'll notice another striking similarity to birds. 3 toes pointing forward, 1 toe facing back. This 3-toed foot, known as a tridactyl foot, is a hallmark of the theropod lineage, and is mirrored in the feet of birds today. It's a reminder that even in the way they walked, theropods possessed characteristics that would later define their avian descendants. Delve deeper, and we find further intriguing parallels. Theropod dinosaurs, like birds, possessed a wishbone, a fused clavicle that acts as a spring, storing energy during flight. They also shared similar respiratory systems, with air sacs connected to their lungs, enhancing oxygen intake, a crucial adaptation for sustained flight. Even their behavior exhibited surprising similarities. Fossil evidence suggests that some theropod dinosaurs cared for their young in nests, much like birds today. This nurturing behavior, once thought to be unique to birds, further blurs the lines between these ancient reptiles and their modern descendants. Chapter 4. The Evolution of Flight, from Running to Flying. The evolution of flight in birds is a tale of gradual refinement, a series of small adaptations over millions of years that culminated in mastery of the skies. Imagine a world where the ancestors of birds, small, feathered dinosaurs, darted through prehistoric forests, their feathers providing insulation and perhaps even aiding in balance and agility. As these dinosaurs evolved, their feathers grew larger and more complex, eventually forming airfoils capable of generating lift. These early flyers were likely gliders, launching themselves from elevated perches and using their feathered limbs to control their descent. Picture them, these pioneers of flight, soaring between the ancient trees, their feathers catching the wind. Over time, muscles and bone structure adapted to the demands of flight. The development of a keeled sternum, a large bony plate on the chest, provided a secure anchor for powerful flight muscles. These muscles, working in concert with the wings, allowed for flapping flight, giving birds greater control over their movements and the ability to generate their own lift. The evolution of flight wasn't a linear progression but rather a branching tree, with different lineages of dinosaurs experimenting with various forms of aerial locomotion. Some, like Microraptor, developed 4 wings, while others, like Archaeopteryx, possessed a long, feathered tail, potentially used for steering. Through this process of trial and error, natural selection favored those individuals with adaptations that enhanced their ability to fly. Over millions of years, these incremental changes led to the emergence of the diverse and successful group of birds we see today. Chapter 5. What happened to the non-avian dinosaurs? Around 66 million years ago, a cataclysmic event shook the Earth, the impact of a massive asteroid, marking the end of the Cretaceous period. This event, known as the Chicxulub impact, triggered widespread devastation, leading to the extinction of an estimated 76% of all plant and animal species, including the non-avian dinosaurs. The impact unleashed unimaginable forces, triggering massive earthquakes, tsunamis and wildfires that ravaged the planet. The skies darkened as dust and debris choked the atmosphere, causing a global cooling effect that disrupted ecosystems worldwide. Faced with such catastrophic environmental upheaval, the reign of the non-avian dinosaurs came to an abrupt end. However, amidst this global catastrophe, a remarkable group of survivors emerged: the birds. Their small size, ability to fly, and diverse diets proved to be advantageous in the face of such adversity. While larger dinosaurs struggled to find food and shelter in the devastated landscape, birds, with their ability to exploit a wider range of resources, were better equipped to survive. Their wings, once adapted for flight, now offered a lifeline, allowing them to escape the worst of the devastation and colonize new habitats. Their beaks, evolved for a variety of feeding strategies, allowed them to exploit food sources that were inaccessible to larger, more specialized dinosaurs. The survival of birds through this mass extinction event is a testament to their adaptability and resilience. They inherited a legacy of flight and innovation from their dinosaur ancestors, traits that ultimately allowed them to weather the storm and inherit the skies. Chapter 6. Dinosaurs are still among us. When you hear birds chirping, remember you are listening to the descendants of dinosaurs. Birds are not just related to dinosaurs, they are dinosaurs, the last surviving lineage. Look closely at birds and you'll see echoes of their dinosaur ancestry. The bald eagle, with its powerful talons, evokes its theropod ancestors. The vibrant plumage of a scarlet macaw hints at the display feathers of their dinosaur kin. Even the humble chicken carries the legacy of its dinosaur past. Its clucking and nesting behavior are reminders of its ancient lineage. From ostriches to hummingbirds, birds embody the diversity of the dinosaur lineage. They are found on every continent and every habitat imaginable. Birds have adapted to a staggering range of ecological niches. As we marvel at a hawk or a songbird, remember we are witnessing the living legacy of dinosaurs. They are a vibrant testament to evolution, reminding us that the age of dinosaurs continues today. Outro: dinosaurs never really went extinct. The next time you see a bird, remember, you're looking at the last living dinosaurs. The great mystery of how dinosaurs evolved into birds has been uncovered, thanks to fossils, feathers, and DNA evidence. From the ground-dwelling theropods to the feathered flyers, we've traced the incredible journey of these creatures through millions of years. Their story is a testament to the power of adaptation and the enduring legacy of life on Earth. The dinosaurs may have faced a cataclysmic event, but their legacy lives on in the birds that fill our skies with color, song, and a reminder that even in the face of extinction, life finds a way. Dinosaurs may have ruled the past, but in reality they still rule the skies.